Ready to get started. Over to you, Gautham.
Awesome. Am I audible? Yes, can you hear me okay? Great. Hey, thanks everyone for coming to this session, and thank you, Deepak, for the extremely kind words. I hope this session is valuable for the folks attending. And definitely we should also try to have some fun while we're going through all this content. Um, so let me just move on to the next slide. So just to be very clear about what we're talking in this session. So when people talk about AI products, they can be in different layers. They can be in different parts of the stack. What we are referring to here is on the application layer, how products use AI, what are like some best practices that I have encountered, what are some lessons that I learned, some lessons learned the hard way, some the easy way. So we'll be going through some of these lessons together. And a lot of people have been asking this question, like, why is building with AI different? Why is this like so special? The short answer is it's actually not very different from traditional product building, traditional product management. The only nuance here is that we have to deal with a lot of non-determinism and a lot of probabilistic outcomes that are introduced into your system because of AI. So what used to just be like a set of rules that an algorithm had to follow now has become a set of probabilities that drive outcomes for your product. So this is like one step change in what's happening because of AI, and it does have some interesting consequences for product builders and definitely for product managers. So we're going to be talking about all of that today. And yeah, like there are some very interesting articles about how to adapt to these changes, how to think about these changes as a builder. We'll be sending out a few articles at the end of the session that you all can go through. One of these is like a famous article called "Software is Changing" from Andre Karpati. So that's like something that you should all definitely check out if you haven't already. We'll move on to, okay, this is like a quick intro, like just repeating what Deepak said. Here's a few, just to show folks like a flavor of what are the things I'd worked on at Google. So I started off with ads, where I was working on targeting quality for multilingual users. And then I got the opportunity to work on the search feed, where we shipped an AI generated podcast. So this is like a fully AI generated podcast, which sounds like a conversation between two speakers, and it's personalized based on the user's interests. So this was I had a lot of fun building this product. I also used to work on personalized notifications on the search app. So like when you do some search activity, Google tries to understand what your preferences are, and then Google also sends out some notifications. For example, if you search a lot of Taylor Swift, and then if Taylor Swift gets engaged, Google will send you a news notification about Taylor Swift because it thinks you're interested in Taylor Swift. So that's another system that I used to work on. And more recently, I've been working on in the enterprise side for Workspace, where we've been doing Gemini features all over Workspace. The side panel is one of those examples. And this is also like a standard disclaimer. A lot of the opinions and concepts shared in this presentation, they're not like, it's not the standard way in which things are done at Google or anything like that. Um, and even in terms of the concepts that I'm talking about, definitely apply your own judgment, see what applies to your case, and take out those parts of these lessons that you can apply on your own products. So just because like someone says, oh, evals are very hard to run, it doesn't mean evals are hard to run for everyone. You have to understand why they're hard for you, what you need to do, and really think from the perspective of your user and your product. So that's just another disclaimer. Yeah, apart from the fact that this is not like official Google content or anything, this is more like my opinions based on products that I've built at Google. Okay. So this is what the session is going to look like. We'll do a very quick primer on machine learning just to like put out some terms and explain some very high level concepts. Then we'll be applying these concepts in product design. So we'll have a couple of case studies of how this can be applied. And then finally, we'll go to like how quality is measured and how decisions get made, especially by product managers. And then we'll have a wrap up slide at the end. So in between all these lessons, there are also places where you all can actually send out responses or ask any questions. So you want to keep this interactive. So definitely like use the chat box for this meeting and like keep sending out responses as and when you see questions on the slides. All right. Okay, so let's just start with this question. What's the first product you used that had AI in it? Or like what do you think is the first product that you used which had AI in it? Just feel free to send over responses in chat. Siri, yeah, it's a good one. Yes, Google search, Alexa, Chat GPT, Google Ads, definitely. Anything else? Amazon Marketplace, yes, definitely. Matching products with users. Netflix is a great one because Netflix was one of the first large-scale successful recommender systems, and it actually proved a lot of things about the viability of the streaming business because of its investments in recommendations. So Netflix is a great one. Midjourney, more recent examples. Yeah, so this is my list, which is very similar to what you all have put in the replies. Google search, again, when we say AI, and just to have this terminology right, we're not just talking about GenAI, we're talking about AI, we're talking about any system. Like this was just machine learning at the beginning. Then we had some advancements, and then now we have like language models. But machine learning is the base, and like AI is what we use as a common term for these systems. So it's not just Gen AI, but any form of AI. So yeah, these are some of the things that were the first instances of AI that I came across. Google search, the OG version of it, looks very different now, obviously. Tagging faces in photos, that's like a really interesting one because it correctly separates out faces from the rest of the image. And that is like one of the early advancements in machine learning that was done at Facebook. So these are some of the examples that I saw. Cool. Okay, so before we dive into all the concepts, the first thing you have to understand about this whole system is like, what is the machine trying to learn, right? So when people say machine learning, the machine here, it is an algorithm that learns to make predictions. So there is some kind of a statistical relationship between input and output, and the machine tries to use that statistical relationship to make predictions about unseen inputs. So think about like I'll just take a random example. People who like the movie The Godfather are very likely to like the movie Goodfellas, right? So next time you go and say, I like The Godfather, like an ML algorithm might say, okay, you're very likely to also be a fan of Goodfellas. So that's because there is a statistical relationship between these fan bases, also maybe between those movies. And so the machine makes these predictions based on those statistical relationships. So there are going to be exceptions, obviously. There might be someone who for some reason just doesn't like Goodfellas, although they are a huge Godfather fan. These are what are called error cases. So there is a the error here refers to a difference between the predicted value and the actual value. So when the predicted value is not the actual value in a prediction, that's what is called an error. It's also called a loss. And a loss function, it constantly measures the difference between predicted and actual values. So take the same example. The loss function in that case, where a system tries to predict if someone is a fan of Goodfellas based on whether they're a fan of The Godfather, the loss function there would be it'll be all the mispredictions, which is like people who were called fans of Goodfellas, but they are not, and the people who were classified as not being fans of Goodfellas, but turns out that they are. So all of these are like losses that come in the system. And what the machine does here is it iteratively keeps minimizing this loss. So that is what the learning process is all about. And there are some concepts we'll send over. We're not going to go into like more details here, but there are some concepts like gradient descent, which is like the way in which the machine actually learns and minimizes this loss with more and more data and with more and more time. So this is just a very high level overview of what the machine's trying to learn and how it achieves its objective. Now, why does this matter for someone building products? This particular, when I said real value and actual value, when I said predicted value and actual value, this whole definition of actual value, right? What does that even mean? The actual value of this prediction system, it actually depends on your product's goals. So let's take some examples so we can just like go through these concepts. So what is the goal of TikTok according to you? So let's say you're the product manager of the TikTok home screen. What do you think is like the goal of that system? Any guesses? Yeah, yeah. I think time spent is usually the most important metric in a lot of video and social media platforms. Yeah, you do have some more granular metrics like average time viewed per user, number of videos watched. So there can be a lot of objectives like that, but it will all boil down to like user minutes or user hours, like the overall time that people just spend on the platform, because that's what relates to their business goal. The more time people spend on their platform, the more they can advertise. And in some cases, the more time people spend on the platform, it's also like the amount of time they spend on the platform is also correlated to how likely they are to subscribe to something. So they don't want ads because they spend a lot of time, so they just pay so that there aren't ads. So in all these cases, it boils down to some form of time spent. Okay. Now, what is the loss function based on like what you just saw in the previous slide? What is the loss function of this next video algorithm? So if you want to maximize the amount of time that someone spends on the platform, a user comes, sees the first video, you want them to spend more and more time. What is the loss that you want to minimize? Yeah, closing the app. That's definitely a loss that you want to minimize. What else? Yeah, bounce rate. Bounce rate is, yeah, basically non-completion. You're not finishing the whole video and you're moving on, or you're leaving the app altogether. All of those are bad things. Next video should be likable. Yes. Okay, so Saurav is asking for the question again. Okay, so if the TikTok system wants to maximize the amount of time spent on the platform, what is going to be the loss function of the next video algorithm? So the next video algorithm is what determines what comes out right after you swipe. Yeah, yeah, yeah. Total number of videos watched before closing. Yeah, I think all of these are great answers. Um, so if you want to keep the user on the platform as much as possible, you have to like reduce the amount of bounces that they do. Those bounces are actually like they may not just be one interaction, they can be different types of interactions. So the algorithm at some level, it tries to optimize for the larger goal. So what happens traditionally in these systems is the machine learning's objective is not just a single goal like maximize time spent. It is expressed in the form of a more nuanced goal, which will lead to more time spent on the platform. So we'll do one more example, and this will become clearer. Um, how many of you get push notifications on LinkedIn? A lot of these push notifications are personalized. They're not just like someone sent you a message or someone like added you. Like those aren't the only notifications. You get a lot of content recommendations as push notifications on LinkedIn, right? So let's take that system where you get content recommendations on LinkedIn as push notifications. What is the goal of this system? Click-through rates, engagement, yeah, increase engagement on LinkedIn, return rate, content discovery, yeah, showing recommendations that are relevant to you. Yeah. Yeah. In usually with any kind of a push notifications system, the highest level objective is growth in engagement. That's why push notifications are sent. Like, and I'm talking about like these content and recommendation type push notifications. People want you to come to the platform more often, and they want you to spend more time on the platform. And push notifications are like a re-engagement tool, which when you target users at the right time with the right content, they'll come back and then they'll also spend more time on the platform. So the goal is, let's just say, engagement growth. All right. That's the high level goal of push notifications. This is on LinkedIn, on almost any platform. Okay. What will be the loss function? So let's say you've hooked on this push notifications system to an algorithm. Like there is a machine learning algorithm which decides which notifications to send to whom at what time. Okay. So this system is now making predictions. So like Deepak, the user will like content related to AI at 10 a.m. That's a prediction that it makes. All right. In this type of a system, how do you think about the actual loss function if your goal is growth? Okay. Muting notifications. Yeah. I like how Vishal went straight to muting notification. Didn't like, yeah, users telling, yeah, non-conversion did not open the notification. Increasing the open rate of push notifications. That is also a part of the equation. Yes. Number of posts engaged. Users clicking on the notification but not spending time. Interesting. Awesome. I think, again, we have all the parts which we need to put together to think about the loss function. Okay. So again, remember that the goal is growth. If you only think in terms of click-through rates, and if you only predict click-through rates, so there's a standard acronym. It's called PCTR. It's called predicted click-through rate. That's used in ads. It's used in anything that does recommendations. If you only say that my goal is click-through rate, what is the drawback of having that as your objective for the algorithm? Anyone? May not lead to revenue. Let's say that number of clicks is, just to simplify this, let's say that number of clicks is equal to engagement. Missing on content relevance. Content might, okay, but if you optimize for click-through rate and you just only send the things that you think users are very likely to click on, it will be relevant to some degree. Yeah. Okay. So there is, okay. So it focuses on short-term engagement and long-term decline. So that is definitely a big consideration for these types of systems. Someone mentioned at the very beginning, they said that people will just mute notifications and you don't want that to be happening. So if you optimize only for PCTR, what happens is that you keep picking notifications that are very likely to be clicked on, but you end up sending a lot of them. That's one option. Or you may have some notifications that are liked by a lot of people, but also like not at all well received by some people, right? So if you think about the worst case outcome, when you receive a push notification, the best thing you can do is click on it and then like spend a bunch of time on the app, right? That is like the best case scenario as someone running the business. The second scenario is like you just ignore it or like you just dismiss it. Then you might mute like a particular channel. You say, I don't want recommendations. And then you have like someone opting out of all your notifications. And then in the complete extreme, you got a notification that annoyed you so badly that like you uninstall the app altogether. So if you think about the spectrum of possibilities, you can't just optimize for having more and more best case scenarios. You also need to make sure that long-term growth is taken into account. And the way to take long-term growth into account is to also account for worst case scenarios. In this case, it's like turning off notifications and uninstalling the app. Uninstalling the app is like, it's not that easy to measure, but turning off notifications is definitely something you can measure. So a loss function in these types of systems where short-term growth and long-term growth may not directly align with each other, the function needs to take both metrics into account. So again, I'm oversimplifying it a little bit, but in this system, the goal of the algorithm will look something like click-through rate divided by opt-out rate. Some kind of a ratio. It won't be this simple, but it will be some kind of a ratio or an equation that takes both clicks and opt-outs into account, because you want short-term growth, but you also want long-term growth. You want people to come in more often right now because of your notifications, but you don't want a lot of people to opt out over time, because like you need to keep them, you need to have the option to reach them in the future. So whenever you think of these types of systems, whenever you're like thinking of the objective function for yourself, don't just think about a single metric. Definitely don't only think about the numerator metric, which is like growth. I want clicks, so the machine learning objective is clicks. It ends up going in different directions if you only think about the short-term angle terms. Okay, now back to like what the prediction itself is all about. So we talked about the loss, and I also gave the example of what the machine is trying to predict. So this prediction itself, it's made on the basis of inputs from your product and to some degree from the user. So like again, there's some random example where if you take a house, its price is a function of its square footage, the current interest rate, the supply in that area, blah blah blah. So there are a lot of these features that go into actually making the prediction, and it applies depending on the product that you're working on. These features might vary by quite a bit. In the push notifications example, the features are related to the content itself and to the user. And then there might be some other externalities, like you don't want to send someone notifications at 3 a.m. So like time of day, that might be another variable. So you think about like what are the most important factors that affect your prediction, and they will all go as features into the machine learning algorithm. Okay. Now we have another exercise, and I mentioned at the beginning that there is a lot more non-determinism that's introduced because of AI, because of machine learning. Let's take this example. So these are both screens from YouTube Music. All right. On this screen, this is like a preset playlist, and I like this is the sequence of songs has already been set for us. So let's say I'm playing this song Sober by Tool. I think it's the 1, 2, 3, 4, fifth song. Now, at the end of this song, an error means that the next song doesn't play. So the next song, it says Man in the Box. That song doesn't play. That's an error. That's a problem. And what the next song is after a certain song, it's just a function of its position on the playlist. So you have this song, then you have the next song. The next song is going to play after the previous song. So very simple world. Let's take autoplay. So here, I chose the same song, but I don't have a playlist. And I've turned on autoplay, and it's just created a playlist for me. This is like a very common pattern now. You'll find this on YouTube Music, Spotify, and all these products. Okay. What does an error mean in this case? So I played Sober by Tool, turned on autoplay. What would you call an error in this case? No song played after, user skipping the next song. Yeah, a lot of great answers here. Yeah, I think you all, this is, and we've all experienced this as well. So again, you can define this error in a few ways, but it will boil down to like the state of your product and what your goal is. So if again your YouTube Music, you want to like optimize for the amount of time spent on the platform, similar to TikTok, you want users to stay on this on like the playlist for as long as possible. So if the next song is irrelevant, then users might skip it. They may not listen through the whole thing, and like in worst case scenarios, they might just exit YouTube Music. Yeah, there's some outcomes listed here by Akhilesh: skipping the song, changing the playlist, changing the setting from autoplay to match, that's a great one. So they hate your recommendations so much that the user just like turns off autoplay and they're like, I'm just going to figure it out on my own. All of these are signals that your predictions are not in the right direction, and users, and we are actually trying to record how users respond to these predictions. So again, what we are seeing here is, unlike regular products, the way you define an error itself can be subjective. There are a lot of right answers, and there are also a lot of wrong answers to what this error can be. So you have to be careful, go back to first principles, think about the product's goal, and carefully choose your error function or loss function, whatever you want to call it, right? If you don't, again, similar to notifications, if you don't pick an objective that takes the whole spectrum of outcomes into the consideration, then you're not going to reach your ultimate goal, which is, in this case, like more time spent on the platform. So the main takeaway here is, think through an entire spectrum of possibilities. Whenever you're making this prediction, what are the things that could go wrong? What are the things that could go right? And choose like the right type of objective function or cost function for your model. And as product builders, this is like one of the biggest inputs that you can give in the whole process of building AI products. So it's not just about, okay, we just have like a model and engineers are going to fine tune it and make it work. Like, you have to think about what is it that you are really optimizing for, and you have to steer the model towards those outcomes. It's not just going to happen in a vacuum. All right. So we're going to do like it's like a reverse Uno kind of thing, right? Because all machines are trying to think like us. In this exercise, we are going to think like the machine. Okay. So imagine you're the algorithm. Okay. And I'm going to play a couple of videos. So you're the algorithm that's trying to optimize for engagement. Okay. Tell me which feed you would prefer. So I'm going to show two feeds. Let's call it, this is the first one. Okay. Okay. So I'm not asking you if you like the actual content that's being shown, but observe the user interactions, observe the way going one after the other with these videos. Okay, so this is YouTube Shorts, obviously. Okay, thank you. So this is the first one. Now let's watch another video. This was my LinkedIn feed. With a lot of hot takes, if I may say. So I'm scrolling through my LinkedIn feed here, and I just took a video of myself scrolling through the LinkedIn feed. Okay. So if you were the ML algorithm that's going to optimize for engagement, which feed would you prefer? Would you prefer the YouTube Shorts feed, or would you prefer the LinkedIn feed? Yeah, seeing LinkedIn, YouTube gets 1, 2, 3, 4. Yeah, so the goal of the product is like, you're going to optimize for engagement, right? Both platforms want you to spend a bunch of time on them. YT, because videos get more engagement. So again, the question here is not about the nature of the content, but it's actually about the scrolling pattern and the way I just went through the feed. That was like, yeah, so you videos in general, you spend more time than text is fair. Like, but um, that's not the nuance. You spend more time. Yeah. Okay. So I'll actually show you the actual difference. Like, obviously video and text may not be an apples to apples comparison, but if you actually look at the user interaction itself, on the YouTube Shorts feed, I was swiping at exactly one video at a time. Okay. So I got a video and I either swiped it without finishing the whole video, or I went through the video and then we moved on to the next video. In the second example, I just scrolled through a bunch of content on LinkedIn. Now, the difference here, apart from the fact that one is text, one is video, um, the main difference here is users' intent in the first case can be established more clearly. So if you actually think like the algorithm over here, what you're trying to do is you're trying to predict who likes what. And if users are swiping or watching entire videos, one video at a time, you have a much better understanding of what they like and what they don't like. Obviously, it's not 100%, but if you don't watch, like there's a 20-second video and you only watch 3 seconds of it and you just scroll to the next one, it's very likely that you weren't interested in that video. Whereas on LinkedIn, you spent 1 second on the first block of content, two on the next one, and then three on the next one. But it's very hard to put a finger on it and say it's because you like the third piece of content more, because the user scrolling action is a weaker signal in the second case. So remember the signal strength of user interactions. This is extremely important for the algorithm itself. If you have a high conviction, strong signal of what the user is trying to tell you, right? That is like way more valuable to the algorithm than like a weaker signal. The strongest signal is if the user literally goes and does thumbs up, thumbs down. So if they come and say, that's why most recommended algorithms have thumbs options, or like interested, not interested, some option where users explicitly state their preferences. So if users come and literally push on thumbs up, thumbs down buttons, it's like very clear what their preference is, but most users don't do it. In practice, a very small percentage of users actually press those buttons. You use all these products and you'll be noticing this, but you still have to make guesses of what they like and don't like. So in the absence of explicit feedback from the user through those types of signals, if you're trying to infer what the user likes and what the user doesn't like, the UX patterns that you use play a huge role in the signal strength that you build. And definitely there are some limitations. Like, unlike YouTube, LinkedIn can't just show you one content at a time. It may not work that well, right? So definitely there are limitations, and everyone can't just copy TikTok and just do the thing that they did with short form videos. But wherever possible, try to optimize for signal strength that relates to user interactions. So try to build the product in a way, if you're going to use a machine learning algorithm that's going to determine like a large part of your product's behavior, try to have interactions where users can clearly tell you what they like and don't like. So that makes a big difference to the quality of recommendations that they'll see in the future. Okay, now that this is done. Sorry, just give me a second. Scroll away. All right. So everyone would have seen like this Venn diagram of UX and business engineering, and like PMs are placed somewhere in the middle, something like that. Uh, I'm not a huge fan of that Venn diagram, but I think there is another stakeholder, which is the model in itself. The reason the model is treated like a separate stakeholder is because the model behaves in a non-deterministic way. The model behaves differently from some of the other stakeholders. So for your product's quality to increase with more data, and with more time, you need to build the product in a certain way. Your user interactions actually need to complement the whole data flywheel. So if you're not getting enough signals, or if you get low quality signals from your user interactions, the model's not going to be able to help you beyond a point. Sure, there are like some, you know, models that will work really well cold start. You can have some pre-trained models that might solve some problems for you, but to have like this, to actually see this type of a quality graph on a product where with more and more users and more data, your product's quality is improving, you need to make sure that the product's UX is collecting as much data as possible, and also is collecting like really high quality data. So this is like the main takeaway from the previous exercise. Now, okay, couple of more questions. So we saw YouTube Shorts or TikTok, which are good examples of it. LinkedIn, I'm being a little harsh calling it a bad example, but it's not as great as like a video feed. So what are other examples that you all have seen now that you saw this concept that even the way you make users scroll on your content has an effect on the algorithm? What are some good and bad examples that you can think of? Duolingo is a really good one, because like completion of lessons is like a very strong signal. In shorts, yes. Yeah, this is another reason why stories, which I think Snapchat came up with stories, and then like a lot of social media companies, they emulated Snapchat. And that's mainly because stories have a similar pattern. Again, it is like short form content one at a time. So you have like very strong signal density coming from users. Tinder swipes is another really, really good example. Like it is the ultimate example actually. So you have like there is so much that you can learn from about someone's preferences because of their left right swipe pattern. The interaction is also very, very simple. So users, the amount of effort they take to express their preference is like extremely low. So Tinder is a really, really good example. Yeah, Reels, yeah, Reels, stories. Understand why Google Discover has a box feed like UX. It is one of it's definitely a factor. Like every time you see this type of a UX where there is clear demarcation between content, like I won't say it's because of machine learning, but it definitely helps the machine learning algorithm. Yeah, bad example, Amazon, people are buying this also. Yeah, I'd say to some extent I agree. It's you can't infer a lot of things from that. Yeah, Swiggy asking for 10 questions for overall feedback. Yeah, but I don't know if there is like some machine learning in their survey system, but yeah. Yeah. So here's another interesting point that doesn't this lead to lower discovery if you keep getting the same type of content? And that is the trade-off to consider. All right. So you are trading off between how much you're showing the user and how much you can learn about their preferences to some degree. The one of the things that you can do here is the amount of effort that's taken to express that preference should be extremely low. Just why swiping is just like, so if you think about going back to those two videos that we played, in both cases, I was just swiping, right? I may have like moved my thumb a few more times for YouTube, but it's not that much different from the number of times I moved my thumb on the LinkedIn feed too. So the amount of actual effort that the user has put for going from one content to the other, that needs to be extremely low. So as long as you're able to manage that, it will lead to the user navigating like a bunch of content. So then you can still do the trade-off. So, but it is a very important trade-off to consider when you're building these systems. Yeah, people. So the serendipity thing that that Saurav brings up here, it's also, so if you look at the way these algorithms work, isn't it lead to lower discovery? We keep getting. Yeah. So okay, I'll try. We can come back to this at the end, but I'll tell you a quick thought here. When algorithms try to recommend this content to you, it's not always the same type of content. So let's say, like YouTube definitely knows that I watch a lot of cricket and basketball, right? So 8 out of 10 videos will be like cricket and basketball, but there will be a couple of videos which might be related, but not the exact same type of content. So it knows that I love these two sports, and then it tries to find like something at the intersection or something closer. Maybe I watch tennis, and then it shows me some tennis content. So whenever these recommender systems are showing new content to the user, there is a mix between known preferences and there is some content that the algorithm shows just to understand more about you, right? So that like you will see a lot of the old stuff, and then you'll see a little bit of the new stuff. The showing a little bit of the new stuff is another trade-off to consider. So it is a risk because like the user might not like it, and sometimes they might really hate it. But at the same time, if they like it, it's great. You found a proper preference. Even if they don't like it, you've learned something about the user, which is still like something that all these algorithms end up using in the future, right? Okay, so we'll move on with the second lesson, which is to be paranoid, basically. So this is Tesla self-driving.
Okay, I don't know why it did that. That wasn't good.
I don't know if folks saw this clearly, but the car is driving itself, and then suddenly
Okay,
it
I don't know
almost
why it did that. That wasn't good.
goes in the wrong lane. Okay, and then like he immediately fixes it. So again, not throwing shade at Tesla. These occurrences are like they're not that common, but the point is like something like this can happen, right? And if you are building products that use AI, you have to assume that some things will go wrong. You cannot just act like things will be fine. You can't just design for the best possible outcomes. You have to design for the worst possible outcomes. So this is like something that I learned the hard way, that prediction errors from these systems they're actually features, they're not bugs. They're not edge cases. They are part of BAU. They are business as usual. Like, and again, this is an example. Like you might see that, oh, we've replaced the customer service center with a bot, and it gets like things right. It sends appropriate responses 95% of the time, and that metric sounds great. But like in the extreme worst case scenario, if things go wrong like one at a time for all your users, you could literally piss off like 1 million users if you have a 20 million DAU business. So things like, oh, it's 95% fine, 99% fine, all of these things sound great in prototypes and in like initial explorations, but you'll have a lot of cost to these mispredictions as your user size increases and as your complexity of the product increases, right? So this is a very quick explainer about how to think about these mispredictions, all right? So I'm sure you've seen this diagram before. It's called the confusion matrix, I think. So what this shows us is like how to look at predictions and actual values. And let's say the system made a prediction, and the prediction and it called, okay, let's take an example. That's the best way to explain this. I'll take a pregnancy test, right? So let's say that I take up a pregnancy test, like someone takes up a pregnancy test, and it comes out as positive, and that person is actually pregnant, so that is a true positive, right? It comes out positive, but that person is not really pregnant, so that's a false positive. If it comes out negative and the person is not pregnant in reality, that's a true negative. And then if it comes out negative, but the person is actually pregnant in reality, then it's a false negative. All right. So it's called the confusion matrix for a reason, because it's like, yeah, you just have to stay on top of all of this framing. It can get a little confusing, but I think most of you should get the idea here. Now, what is precision and recall? You'll see this term very often in while talking about machine learning, talking about AI. So precision is the number of true positives divided by your true positives and your false positives. So going back to the pregnancy test example, out of all out of all the people who were classified as pregnant, how many were actually pregnant? That's what precision means in this example. And in terms of recall, we are actually talking about out of all the pregnant people in the sample, how many were correctly classified as pregnant. Okay, so you understand the difference. In the case of precision, it is referring to, like, the denominator is referring to positive predictions. Out of that, how many were actually pregnant is what precision measures. And then in the case of recall, the denominator is out of all the pregnant people in reality, and how many of them were correctly classified as pregnant by the system. So this is like again, like the example, like if you actually apply precision recall to this example, slightly awkward example, but you should get the idea of what these terms really mean. Okay, and the reason I introduced this, okay, please explain one again. Okay, I'll explain with numbers. Maybe that's the best way to do it. So there are 20 people, okay? 10 of them are pregnant, 10 of them are not, okay? So are you following? 10 people are pregnant.
Gautam, can you be a bit slow? I will just noting it down.
Yeah, let's do it. So there are 20 people in a sample, 10 are pregnant, 10 are not. And they are all administered a pregnancy test, okay? And the pregnancy test says that 11 people are pregnant, 9 people are not, okay? So in reality, 10 are pregnant, 10 are not. The test was taken, and then 11 positives and 9 negatives came out in the test. So the precision rate here is, if you, in the denominator of the precision rate here is the number of true plus false positives, which means the number of people who were classified as pregnant according to the test. That is 11, right? So that is the denominator for precision. The numerator for precision here would be the, out of those 11 people, how many were actually pregnant? All right. So that need not be 10. So that's the part to note here. So in that whole sample, there are 10 people who are actually positive. Your test said 11 people are positive. Out of the 11 people who were classified as positive, how many are actually positive? Okay, that is what the precision rate measures. Recall is going to be out of all of the people that were actually out, like now the sample has 10 in reality there are 10 pregnant and 10 non-pregnant people. So according to recall, the denominator will be 10. All right. So that is the actual number of pregnant people. So if you see this matrix here, true positives and false negatives. So false negatives plus true positive is basically this column, which is like real label positives, right? So the denominator here will be 10, and true positives are the ones like out in your particular system, you actually marked 10 people came as like the overall positives, right? So in your system, the classifier said 11 people were actually positive. So out of the people who are actually marked as positive by your system, how many were actually positive? That's what you're looking at over here. Did folks get this? I think I need like a better diagram to explain this the next time. Maybe this is getting missed a little bit. Should I try again, or are folks understanding what this represents? Yeah.
So Gautam, maybe what we can do is just in the side chat,
I'll find
write out the numbers and
yeah.
explain and say, hey,
Let me
TP, this is TP plus FP, therefore precision equal to what the value is. Likewise for recall, and the initial condition saying what the test and what the
the
test.
I think
gave.
this
It
is
may be
like
easier for them to read it on the chat.
Yeah. Let me send this. Maybe we'll send this. We'll come back to this later. Yeah. We should have put numbers on this slide. I'll just take up this feedback. Okay. So let's on to when you actually design products. When you actually design products that have some kind of a cost for mispredictions. The previous examples of precision recall, like those concepts are important because like the cost of a false positive and the cost of a false negative, it's not going to be the same in most cases. Okay. Let's just take like real world examples, right? Let's go back to the TikTok recommender system. Okay. So the recommender system in TikTok, it says that, okay, this is a video that you like. All right. That is the prediction that it makes. And it thinks that you like this video, and then it shows you a video. What is the cost of a false positive and what is the cost of a false negative in this case? Just like what could happen if it's a false positive, what could happen if it's a false negative in this case. So let's actually define what false positive, false negative means in this case, right? A false positive is TikTok thinks that you like this video and shows it to you, but you don't. So that's a false positive. A false negative is TikTok thinks you don't like this video and it doesn't show it to you, right? So like TikTok thinks I don't like basketball and it doesn't show it to me, but I actually like basketball, right? So that's what a false negative is in that case. So tell me this, what is worse for TikTok? Is a false negative worse or a false positive worse? Yeah. Yeah, false negative. Yeah, in these types of conditions, false negative is worse. So you do have, again, it's not always true, but the cost is okay. So a user sees like one or two videos that they don't like, and they just scroll over. The cost is like it's not that high. But if there are some videos that could really pull the user onto the platform, you do want to optimize for high recall. So here in this situation, you want to, if there are videos that a user like really likes, you want to make sure that you don't miss showing it to them. But if they don't like it, it's something that's okay. The exceptions are when there is some inappropriate stuff. Okay, awesome. So Abhinav has put up an example there. Like if you have some kind of an inappropriate video, the stakes are a little different, right? Okay, let's do the other way now. What is a system that has a very high cost of false positive, but a low cost of false negative? Anyone? Yeah, spam is a really good example. So in the case of spam, a false positive is something that is not spam, but gets marked as spam. And if that can be like an important mail. So the cost of that misprediction is actually higher than like if you get one or two spam emails that were not classified as spam, it might still be fine. But if you miss like an important email because it was classified as spam, that is definitely like a worse outcome for you. So the spam classifiers are a good example of like the top left quadrant. Another one is like if you think of so there are a lot of these systems being built to predict crime. Like I don't know how like the ethics of it and all that, but I'm not commenting on that. But in a system that predicts crime, a false positive is that you basically called an innocent person guilty, and then on a false negative is you called a guilty person innocent. All right. And then if you see the actual judicial systems of like most countries, they optimize they try to reduce false positives. So you don't want an innocent person to be called guilty. That's worse than letting a guilty person walk. Again, there are exceptions, like violent crimes that they might go out and commit crimes and so on. But that's another example of this happening. Okay, the reason this whole thing matters is because whenever you're building the UX for your product, think about the cost of both false positives and false negatives. All right. If your if the cost of your false positive is high, then you do need to look towards higher precision for your algorithm. You need to like build higher precision. If you want to have some kind of a human in the loop, their role would be that of a gatekeeper. So the gatekeeper checks the model's work and they reject bad decisions. Okay. So again, going back to the judicial, the preventive crime prevention system, like a human in the loop will make sure that no innocent people are actually marked as guilty. So what the gatekeeper does is they go and actually reject some of the bad decisions made by the model. If you take this other quadrant, and if you want to have a human in the loop, in this case, they play the role of a scout. So scout fills the gaps left by the model. So that's the difference. Like people talk about human in the loop systems in AI in all these places, but what should the human be doing depends a lot on the cost of your false positive and your false negatives. A scout fills in the gaps left by the system. So if you take the case of TikTok, again, TikTok doesn't really have a human in the loop, but let's say that it does have a human in the loop. What it would be doing is making sure that more and more like preferred videos are picked and like videos are not missed out. So here the human actually fills in the gaps left by the model. In the other case, the human is actually like rejecting the model's bad decisions. So they play very different roles when employed in these systems. And thinking of the cost of false positives and false negatives is how you decide what to do with the human, right? The last thing I want to mention here is these costs are not static, and these costs, it also depends on like the likelihood of false positives and false negatives. So those are the other factors to consider when you think through the entire UX of your product. So in a lot of cases, the answer will not just be binary. It will depend on a lot of factors. And like we saw previously, like just a misprediction in itself is not very easy to define. So you need to think about all of these things while determining the UX for your product. If both false positive and false negative costs are very low, then you don't need a lot of intervention, and you can just let users interact directly. If they are both very high, like there are a lot of other questions that come up, like and let's say they are also happening frequently and their costs are very high, then should you even be using machine learning or AI in your product? Is like, I think that's another question you need to ask. Okay, I think we're over time, so let's go quickly. So again, just incorporating the fact that things can go wrong. This is how like a lot of the chatbots do it right now. So here I asked like this paranoid question. I was like, hey, I saw this mole. Is this a big disease? Right? So chatbots do answer these types of health questions, but they have this massive disclaimer saying that, listen, I'm just an AI assistant. I can get things wrong. Go see a real doctor, right? The reason they are doing this is because there are like high costs of mispredictions. So if AI just confidently gives you medical advice when it's not specialized to give you that medical advice, there are like accidents that can happen, and they do happen. You see a lot of cases of users like taking advice to literally doing some stupid things. So nowadays, if you see all these chatbots, they have like a ton of disclaimers, and they're also trained towards like not just listening to the user, but to also get to an accurate answer on their own. Right? Okay, definitely, I'm not going to explain how LLMs work. There is a lot of material out there. We're also going to send over a few links about how we got from basic machine learning, curve fitting models to neural networks, to transformer architecture. It is a lot of material, and like I don't think we can cover that here. But there's a lot of material out there for folks to read up. The reason I just put this slide out is that the LLMs actually take all this non-determinism to another level. And you may have seen this on your own. If you ask ChatGPT or Gemini a question, and then you ask the same question to it like right after, you're not going to get the exact same answer, and you actually don't know what type of answer you'd get, right? So that is kind of like the fundamental property of non-determinism, where the same inputs can lead to slightly different outputs when they're run over and over again, right? So when you're building GenAI products, this whole idea of things going wrong, of things being non-deterministic, you need to always keep that in mind. And that was the point of that slide. Okay, so now the other trend that's been happening is with AI agents. AI agents, a lot of them are multi-step, multi-turn type of agents. They don't just do one task. Yeah, we'll send over the recording and the slide later on above. Okay. Cool. So if you take AI agents, they don't just do like one task. They do like a series of tasks, right? Let's take a random example of an autoresponder agent. Imagine you have like this magical agent that just continuously processes your unread emails, understands how to reply, okay? Because this agent, it can search all your personal documents, your personal life, and it can also search the web. And then it can write responses in your style and just automatically send it out to people. All right. So like this is like half our jobs, I guess. Like it just keeps happening on its own. You don't have to touch it, and this just sounds wonderful, right? But now think about each step. So in the first step, it processes your unread emails, and this step works really well, like 90% of the time. Understanding your personal context and the web and making all those searches, that step works like 80% of the time. And then writing responses in your style and sending them out, that step works like 80% of the time. So in isolation, these steps might have like high 90s, 80s type of accuracy. But if you actually multiply all these ratios together, you finally end up with a product that works like roughly half the time. So it's like 90% multiplied by 80% multiplied by another 80%. That leaves us with 57.6%. So it's suddenly it's not so delightful because you have compounding error rates. So when you had just one task for the particular model, it was like doing it pretty well most of the time. But now you're using the first task to then complete the second task, and then you're taking the first two tasks to complete the third task, and you created like this sequence of tasks for the model. When you're building these types of systems, you have to watch out for the overall error rate, which compounds with every additional step. So this is again a trend that's been emerging because of agents. A lot of them are multi-step processes, and when you have multiple steps, you're going to keep adding up the error. So just watch out for this when you're building products. Okay, and in the previous thing I said it works perfectly 90% of the time, right? So what does perfectly mean? Who defines perfectly, and how do you measure perfectly, right? So most of the foundational, what is the workaround? Yeah. So the workaround for okay, we'll come to these questions at the end, but definitely I'll come and answer these questions. Okay, but I want to cover a couple of concepts, and then we'll come to these two questions. These are very important questions. Okay. Yeah. So when we saw the previous step that something happens 90%, 80%, and all that, right? So when foundational models, like when ChatGPT releases a new version, or like Anthropic releases a new version of Claude, they are kind of telling you that, hey, our models work really well. Here are all the tasks that they are really good at, and then they release something called a benchmark score. So you may see this type of an announcement with like benchmarks listed. So benchmarks are like standardized tests. So it's literally like like CAT or JE, but for models, right? So imagine you have some 100 questions that the model is supposed to answer. So those 100 questions are fed to the model. And then how many of those questions does it get right? That is what the final score of the benchmark indicates. So if you see a score like this, like 59.4% on the graduate level reasoning benchmark, it is literally a set of tasks that the model is asked to do, and then it's scored on how well it does those tasks. So a lot of these benchmarks are the way these tests are conducted is a little opaque, because like a lot of the labs and these companies just run these tests in their environments. And if you're choosing between models, or if you're choosing how to use a model, I would recommend building your own evaluation. So how well is the model working for you? Like the benchmarks give you like some very high level idea, but you should definitely not trust benchmarks to make decisions for your products. And you should actually define your own evaluations for your products, right? And what are these evals? Again, like I said, similar to benchmarks, you define a set of tasks and you ask the model to perform those tasks. And now you're rating the model's output on some dimensions that you defined for the product. And finally, you're like giving out a score for yourself, right? So take this example. So this is I hope folks can see this, it's a little small, but if you're trying to replace, if you're trying to add a chatbot into customer service, your evals will look something like this. It's just something that I made up. So the tasks that the model has to perform, they are basically, it's about answering user queries of different forms. What types of queries will the user ask is completely dependent on your product. So here I've taken up some random e-commerce example. So the user can ask, where is my order? I need a refund. Why is my order taking so long? Right? So these are all types of questions that users might ask. So these are the tasks that you give the model. Apart from the user queries, you will also give it some context. So when the user is asking, where is my order? If you think about what an actual customer service agent does, they look at a dashboard where they will see the actual status of the order. They'll look at the ETA, and then they'll give a response. They'll also have a playbook of how to respond to customers, and then they will give a response. And you do the same thing for your model. So you feed those inputs to the model, you give it the context of what the current status is, what the ETA is, and you ask the model to respond to you. So imagine you're trying to use, just like an example, you're trying to use a Gemini API for building a customer service bot. You will basically send the API this prompt saying, where is my order? And in the prompt, you will also say that the actual status is like it was confirmed with the restaurant and the ETA is 8:30 p.m. because that's how you construct the entire context for the model. And now you look at the model's response. And then these are the actual parameters that you rate the response on. So if you see the last three columns, you have these questions like, was the response factually correct? Did the response contain inappropriate language? Did the response correctly answer the user's question? Okay. So these are questions that you are defining. These are the parameters on which you're actually evaluating the model's output. And these parameters depend entirely on your product's goals. So just again, zoom out a little bit and think about what we're doing here. We are seeing if the model that we are using is a good fit for our use case and for our users. So we are trying to imagine like different scenarios that might happen when we deploy this product. That's what these user queries, like that's what the tasks are. And then we look at our product's goals, which is that we want high customer satisfaction, we want high return rate, and we want users to feel happy about the service that they just received. So if those are the goals of customer service, what are the parameters and what are the questions that you need to ask against each model response? Putting this all together is what will be the eval in this particular example. So you can take any example, and you want to introduce AI, you want to put a chatbot into your product for some reason. It is the same set of steps. Think about all the scenarios that are important to your product, construct these tasks based on those scenarios, and then think about what are the goals of your product, and set parameters for rating that relate to your actual product's goals. So there are a lot of standardized questions that people ask, like appropriateness and like factuality. These are all like questions that you'll see in a lot of evals because they're just like commonly useful. But there will definitely be your product specific questions that you want to ask. So in this case, I've added a parameter saying, did the response correctly answer the user's question? So it's not just that you want to be appropriate, respectful, and factually correct. You also want to be useful. You also want to actually answer the user's question. Again, the number of questions in this case is you need to, like any sample, you need to have a size that's significant enough. So imagine that you just run this. So let's say we compute scores. Okay, so we're computing correctness score and factuality score, something like that. If you compute that score over 3 tasks, you'll get a certain confidence interval for that score, which will be like pretty high. So the confidence, you want to make sure that your confidence interval is good enough for your product. So usually you'll want hundreds, if not like thousands of tasks. And in terms of parameters, again, it completely depends on your product, and it completely depends on how you're setting up your evaluation. There is no like fixed number, right? So this is it will depend on, once you start running these evals, you look at the output and then you are thinking, okay, is this actually helping me understand quality? That's the question you need to keep asking yourself, and you keep like fine-tuning that the whole template of the eval based on that question. So again, I'm just like, I don't want to throw numbers out there about how many parameters you want, but it's usually not more than like 10, 20. At least the products I worked on, I've not had like an eval template where I've asked 20 questions for a task. Because like the usefulness of asking a lot of questions is also, it goes lower and lower. So you have to, it's better to be crisp about the number of parameters and questions, and only pick the ones that really relate to your product's quality and your product's usage. Don't just throw in like random questions and parameters, right? Should evals also contain whether, yeah, so okay, so I'll answer just a couple of questions, which is like, should evals also contain whether AI is divulging unrequired information, and is it commercially viable to test all models? A lot of the foundational models, they do come with a certain level of safety. So you don't have to evaluate every single thing. For example, like you will see that when you're trying to integrate a new model, you will see that they'll make some promises around, like they'll never use inappropriate words, right? So they will already have some safety mechanisms put in. So you may not have to evaluate every single thing, like every single safety aspect, but it is in some cases, you do want to just make sure that the model is giving appropriate answers. So again, remember that safety, appropriateness, these are some subjective parameters, and it depends on your product. All right. So I'll give you an example. Like when we built the audio, the AI generated podcast, we realized that only looking at text is not sufficient to understand whether something is appropriate or not. Right. So the text might just say, yeah, sure. But then the way yeah, sure is said may be considered inappropriate sometimes. So if the AI says, yeah, sure, that's not as appropriate as just saying, yeah, sure. So in this case, just rating the text alone was not enough. And we actually had to play the audio and actually like make the ratings based on the audio itself, because appropriateness is not like just something that's very objective. It does depend on your product. Okay. And yeah, when you say okay, so I'll just get a terminology clarified before we move on. So this entire process is an evaluation. When I say 10 to 20, I mean like the last 3 columns here, which are the questions. The questions are the attributes used to rate each response. This, like each row here is a task, right? So each row here is a task. The first 2 columns are inputs. The third column is the model's response. And then the last 3 columns are the rating parameters. That's how you read this particular eval. So in terms of the number of tasks, you want to have as many as possible. So you want to do like hundreds, maybe thousands in some cases. You build up a big enough evaluation so you can actually measure your rating parameters significantly. The number of parameters, usually you don't have too many parameters. You'll have like maybe 10 or 20 parameters. You won't have more than 10 or 20 parameters. In some cases, just like 5 or 6 parameters are enough. And you can take some parameters for granted because of like the promises made by the foundational model, and then depending on the risk level for your product, you can add more and more parameters. And like I said, the appropriateness example I gave is because the audio format is a new way in which things can sound inappropriate. We had a separate question about appropriateness there. So again, depending on your product, you may want to have more and more types of parameters. All right, and the last, I think this is, oh yeah, we're almost at the end. We'll just do questions after this. So evals are like extremely important, but they're also extremely hard. So just if you think about this, the task set that I showed you previously, how it works in practice is that, okay, you have these 100 tasks that people have to rate. This is given to 3 or 4, I'm just giving an example. This is given to 3 or 4 raters. And then like the raters go and actually mark all of those parameters, yes or no. They go and tag each thing as yes or no. And finally, you come up with a score. But when you run this process, you will find that, for example, one rater will find something appropriate, another one will find it inappropriate. So this is called rater agreement. Like when 2 or more raters don't agree with each other, your evals become less reliable. Another problem is like raters might think that something is perfectly fine, but your actual users may not feel that way. So I'll give you another example. Let's say let's just take this particular example itself. Let's see row number 3, all right? So it says someone sent in caps, why is my order taking too long? By the way, this is all hypothetical. Okay. And then like the model responded saying, stop shouting. Okay. So this is something that, and then if someone actually comes and if one of the raters said this was acceptable, and then you're like, okay, my raters have said this is acceptable, and I'm going to put it in front of users, and then users are like, oh, this is completely unacceptable, and they take screenshots and they shame you on social media. Like, so it can happen that your rater preferences don't align with user preferences. All right. So these are all challenges that can happen with human evals. And someone mentioned, can we also use auto raters? I.e., can we also use another eval LLM to do this rating? So imagine that instead of asking humans to do this rating, this yes, no, yes, you ask another model to come and do this classification of yes, no, yes. That is fairly common these days. So in a lot of cases where the parameters are very well defined, and you can give very good prompt instructions to another model to do the classification, auto raters are used. And like in terms of determining where to use like eval as LLM as judge versus eval as scored. Okay, I don't understand this question. We'll come to this question towards the end. But if you want to actually think about how this whole process works, you usually do this rating like with human raters at the beginning, understand how these metrics look, and then you can make decisions on whether you can have another LLM to do the rating or what you need to refine and so on. The main points to focus on here is you need to have a very strong intuition about like what can happen on your product, what are the best and worst case scenarios, and you need to design your tasks in a way that represents this distribution of scenarios in your actual product. That is one. The second one is you also need to set up the right incentives for the team that's working on quality. So what we don't want, see a raised hand, we'll just come there in 1 minute, Bhuvi. So what we don't want is we've just created like this set of tasks that are easy, and then the model scores like 99% and we're all very happy and we launch things. That's also something that you don't want while you're designing an evaluation. You need to make sure that the tasks are distributed like your actual product. And remember that this is a very, very iterative process. You're not going to get this right on the first step. And also like decisions like when to use an eval LLM and when to use like a human judge and so on. There are some practices, but the best way to find out is to just try this and iteratively keep improving your process. And the way you improve that process is you run an evaluation, you look at the outputs, you make some changes based on the actual evaluation results, and then you see if that's actually making a difference to the quality. Like you see if users are actually, let's say your evaluation has come out to be like top notch, 99%, everything's great, but our users actually feel that way? Do users actually say this is great? And if the answer is no, then you need to like go back to your evaluation. Then there's something missing in your evaluation and you need to like fix that. So you're not going to get this right on the first step. So, but having some evaluation to start with and then like constantly iterating on it, that's how most teams do it. And that is like that's the only way to do it right now. Don't expect to like hit a silver bullet at the very beginning. Okay. So just a quick summary and we'll get to all the questions. Again, if you're thinking about AI products, the processes are still based on first principles. You want to drive user value. You want to have something that's high quality. This is not like an AI technology specific thing. It's just that there are a couple of additional steps you need to take to handle this non-deterministic system. So just like any regular product, you're doing all the steps, but the differences are like, one, you're actually treating the model as a stakeholder. You're accounting for its nuances and its unpredictability. Then you're also like having evaluations which are run, because like the model is again a probabilistic system. You want to constantly evaluate it. You're making decisions not just based on experiments, but you're also like looking at eval results to see if you can move forward and like, or if you want to make changes to your product. So this is like a very high level summary. We will open up the floor for questions. Like Deepak, how do you want to do this?
Yes. So what we'll do is, I think there are already questions flowing into the chat. So maybe we'll start with those questions already. And then once we've addressed those questions, if we have still some more time, we can probably take a few more fresh questions. So before we get started with the questions, I'm going to request the audience to start sharing feedback on the Google form that I've just shared. So this will help us because we do have plans to do more, and your feedback will help us. And Gautham will also then say, hey, what else could we do the next time around? So please do take some time to fill up the form. And as you're filling the form, Gautham, maybe we can now start with answering some of the questions that have already started flowing into the chat with relevance to the evals and all that recently start off. And then we can probably address and go backwards to all the other prior questions as well.
Okay, sweet.
Deepak, we require access to open the Google form. Can you please
sorry, let me change that. Yep, it's been done. Gautham, over to you.
Okay. Which questions do we go to? I think we stopped answering somewhere. Okay, I'm going to. Okay, compounding error. What is the workaround for compounding error? Do we need a human in the loop at every step? I don't think we need a human in the loop at every step. You should, again, go back to that framework of the cost of mispredictions. I'll give you an example. If you want to have an AI that creates documents for you, right? You're just like, okay, create a doc for me with a report of all the e-commerce companies in India or something like that, right? And that particular AI, that particular agent has created that report, but it's fully based on e-commerce companies from the last decade. It's not based on recent companies. So what has happened now is you have to go read that report and make a bunch of changes, which ends up creating like more work for you. So your whole point of using an agent like that might get lost because you wanted to save time, but because it went and did a bunch of things without asking you, it actually created more work for you. So human in the loop in that case is how you build human in the loop is, and you'll see this in a lot of AI chatbots right now. They'll give you some kind of a plan. And especially you should try out like the deep research features of ChatGPT or Gemini. What it does is before doing this big process, it will say, hey, here are the steps I'm going to take. Are you actually okay with me taking these steps, step A, step B, step C? So if I don't like any of these steps, I intervene at the beginning and say, okay, do a different search. Okay. So things like these will actually help users save time or like get to their true objective. So that is the trade-off you need to think about for human in the loop. You are creating an extra point of friction by having a human in the loop step, but what are you saving the user from because of adding that step? That's the question you need to ask. And if you're not, like, let's say I'm just saying hi to ChatGPT, and ChatGPT responds with, are you sure you want me to say hi back to you? Like, that's not a good use of human in the loop. But if you go to ChatGPT and say, make investments for me. I know this is not there yet, but in the future, if you go and say, create an investment plan and invest $1,000 on my behalf, it will definitely come and create a plan first, show you the plan before making that investment. So that's just like how you think about it. And how can we combat these error rates especially for the compounding error rates problem? Yeah, human in the loop at the right moment is a great way to combat compounding errors. So instead of letting AI compound every single step, you are asking it to pause at some point, check with you before proceeding further. That's definitely one way in which these error rates can be combated. Another problem that I've seen happen regularly is more than the prompt, it's actually the context, the way the context gets constructed for the model, where a lot of errors happen. So ensuring that you're constructing context in the right way, you're putting together the right documents, you're retrieving the right type of files or whatever for the model. I feel like checking that step is like way more important. Okay. Another question. What is the I think I answered the suggested numbers. What else is here? I think we can take live questions if there are any.
So my request is, audience, just raise your hand. And then as we start seeing the hands, we'll just call out your name. Otherwise, if everyone starts speaking at the same time, it can get a little messy. So just quickly raise your hand if you have a question, and we'll just call out your name, and then you can unmute and ask your question. Yes, Rohit.
Yeah, thank you, Deepak. Hey, Gautam, I have just one simple question. Like, there's a lot of information regarding AI and so many resources, courses, and books. If you have to just suggest, like one basic resource, what would you recommend?
I also refer to multiple sources. Like one place where I discover a lot of interesting content is Hacker News. So definitely stay on top of Hacker News. You keep seeing some new research, some new papers being talked about over there. Then there are a couple of really good YouTube channels which have good explanations of these concepts. We'll send those over as part of the follow-up. And a few people to also watch out for. Andre Karpati, definitely, like you should follow the things that he's saying. And he also gives like very good detailed explanations of concepts. So his videos and his content in general has always been like super helpful. And again, like I don't have one source like that. I just like look around whatever. I get a lot of things from Twitter or LinkedIn, and then I just see who's written it, and then I decide if I should read it.
Oh, okay. Thank you.
So, folks, I've just shared a small Google Doc, which all of you can read, which has links to all the articles and concepts that Gautam would like for you to check out as well. Any more questions, folks? Yes, Avinav.
Yeah. Hey, Gautam. Hi. Nice session. I just wanted to know your views of using eval params like faithfulness that Ragas uses and blue, rouge. So do they actually, because there's a lot of documentation around it, but do they actually, are they used in real enterprises?
So blue, rouge are so those metrics are actually like they've been around for quite a while. If I'm not wrong, it started in the machine translation days, I think that's where like Blue and Rouge were used. This must be like mid to late 2000s when they were introduced. At least that's when they were used in a lot of companies back then. Nowadays, people have a lot more customized evaluations. So I definitely recall using Blue and Rouge for like a machine translation product that I've seen. This was like maybe 4 or 5 years back. But nowadays, I'd say that folks have gone past Blue and Rouge and they come up with more nuanced, more detailed metrics than that. So Blue and Rouge were more appropriate in the language model era. So this is like before large language models. When you had language models that did single tasks like translation, that's where they had like these specific metrics, and they were like industry standards. But these days, people come up with their own metrics. For example, at Google, depending on the product, you will have your own eval quality metrics. And it makes sense, right? Like YouTube and search will not have the exact same eval quality metrics. They'll have like their own set of eval quality metrics that make sense for them. So yeah, I think the industry standard metrics maybe they are used in some contexts, but inside companies, especially inside product companies, it's become like very customized now. Like two teams working on different products are most likely going to use their own metrics. They're not going to use standards.
Understood.
Yeah.
Yes, Mohammed?
Yeah, thank you, Deepak. Hi, Gautam.
Hello.
And so my question is maybe a step back, right? I mean, how do I think about that when to build AI product? Maybe at Google, I mean, it's such a mature company, right? You have a lot of chance to think about like, yeah, we have already built some, not basic, but we have built all kinds of feature. And I know a lot of places where AI can be plugged in. But for a mid stage or an early stage company, where, I mean, how do I actually think about it? That if AI product is the right way for me to go, or should I focus on other priorities as a PM?
Yeah, I see. It comes down to first principles again. So if you're actually adding AI to the product, like what is the ROI of it? It will come down to some kind of an ROI calculation. Okay. Take the example of TikTok. Okay. TikTok didn't always have like this machine learning based recommendation model. They just had like some rules by which they just like created some sequences of videos at some point, like long back, right? And then after they switched over to an ML based recommender, they saw value. They saw that like recommendations became more relevant, which meant more people were spending more time on the platform, which was leading to more revenue. And that is like the case that was made. I'm assuming that was the case made at some point to switch over everything, right? So in the case of recommender systems, I'm just talking about that example, using a machine learning based algorithm, it is definitely an ROI calculation. Does it increase your engagement, and at what cost? And then if that's worth it, then you do it. If it's not worth it, you don't. On the other side, you may also be using it for some kind of a cost saving, like a lot of the chat service, customer service chatbots are like on the cost saving angle. Again, are they able to deliver high quality, and like how much costs are they actually saving for you? And then how much costs are you incurring because of them? Like, so that's the whole equation that you use. So in terms of the actual usage of this technology, I think it does finally boil down to some kind of ROI calculation. That's how it should be.
Sure. Just one last thing. Can you please explain the confusion matrix once again?
Yeah.
I mean, if you can send it later on, that's also fine. Yeah.
I sent an article that did a better job. I think without like this. So this is the diagram that I should have shown. So okay, let me just present this image alone. Okay, so this is a spam classifier. Okay, So in this case, there is this is actual values, right? So whether this was actually spam or not, and then this was predicted spam or not. So there in total there were 600. So a bunch of emails were sent to the spam classifier. Okay, out of all those emails, the classifier said that 700 were actually spam. Okay, so this whole column of predicted spam means that you fed a bunch of emails to the classifier, and it said that 700 emails were actually spam, and 9,300 emails were not spam. So this is what the output of the classifier was. In actuality, that is what this is. In actuality, the number of actual spam emails was 900. So it's the sum of these two cells, this whole row. And the total number of non-spam emails was 9,100. That is this whole row. So that's the actual non-spam rate, right? So in this case, the precision value is actual spam, which was actually predicted spam. So you take this number, just 600, and the denominator is TP plus FP. So the denominator is 600 plus 700. So 600 plus 100. So the precision value here is 600 by 700 in total, 6 by 7. What it means is, out of all the predicted spams, so the classifier said 700 things are spam. So out of the things that were called spam, how many were actually spam? That is what precision means. So it has the classifier has said like 700 is spam. Out of that, how many are actually correct? So that is what precision means. Recall, on the other hand, is this number. So in the same example, the numerator is the true positives, which is 600, but the denominator is in reality how much spam is there. So you have like 900 spam emails. Out of the 900 spam emails that exist, only 600 were correctly classified as spam by the model. So out of all the spam email that exists, how much was recalled? That is what recall actually measures over here. So here the recall rate would be 600 by 900, 6 by 9. In that case, and the precision would be 6 by 7, which is over here. Was this better? Do you understand the concept here?
Yeah, I think much better. Thanks so much for that.
Yeah, no, next time my slide, I need numbers upfront. I feel like that's the lesson here. Yeah. Okay. Cool. Any other questions? Yeah, Corbin.
Hello.
Hi. Hi, Corbin.
Yeah. So I joined the session midway, so I may have missed some key points. I just want to know from your experience, what are the most, I think, the practical steps for someone trying to build maybe an AI app layer for enterprise use case? Because as a software developer, I know this is quite technical, but I want to share these enthusiasms to my factory workers. So let's say the team has deep domain expertise, but they have no background in software developments. Yeah. Thank you.
Yeah. So I think there are a lot of tools out there. Definitely there are like vibe coding tools where you don't really need to know how to write code, but like you can literally describe what you want to do. And you have like several tools that write code for you, test code for you, deploy code for you. So definitely look up prototyping and vibe coding tools. Basically, you need to play around with this quite a bit before you build some amount of confidence and some level of comfort with using the technology. If you have deep expertise in some particular domain, that's great, because you understand the nuances of the domain pretty well. You know how things can go wrong. Like you have a very nuanced perspective of what is great and what's not. So try to incorporate that. And with the growth of all these tools, you can literally type out those nuances and incorporate that. So my very high level advice is to play around with prototyping and do like some lightweight evaluations. So you're saying, okay, instead of this, I will use AI. Just like before building full-on evaluations and templates, just try that in different cases. Try that in cases that actually matter to you, and see what the response is looking like, and see if that actually makes sense to you. So one thing that a lot of product teams do is we do a lot of bug bashing within the team. So someone says, oh, hey, we have this new idea. They prototype it out pretty quickly, and then the whole team kicks the ball around, and we just try to like test it out in different ways, and we see what are places that are delightful and what are cases where it's like not doing a great job. So yeah, build a quick prototype, play around with it quite a bit, and then try to build some conviction of like what is working and what's not, and apply your deep expertise and nuance while building that conviction. That would be my advice.
Yeah, but how to ensure that we can get like the better accuracy over time? Let's say, yeah, we have tried several vibe coding tools, right? But as a result, the result is not great. Maybe sometimes it's worse than the human judgment self. But how to increase the accuracy over time? Because when we try to change the LLM models as well, sometimes it didn't help at all.
Yeah, I'd say that try to break up your tasks into like smaller pieces, and test them in smaller pieces before you put everything together. So one thing that happens is that nowadays our prompts in general have gotten a lot more complex. So we write like an entire essay, the model, and then they have gotten much better at understanding really long prompts. But at the same time, what you lose out is like having a component level understanding of what's going wrong and what's doing well. So try to break up that idea into some smaller pieces, and then write prompts for like smaller tasks before you try expanding it out further. So the more you keep complicating your prompt pipeline, the more you keep adding bells and whistles to your system, there is going to be a larger probability of error. So start small, get the small components right, and then do the expansion. That would, I don't know if that was directly helpful, but maybe if you want some pointers on specific tools that would help you do that, we can send that to you. I can take up that action item.
Sure. Thanks. Really appreciate it. Thank you, Gautam. Thank you, Deepak.
Sure.
Next we have Abhishek.
Hey, hi, Gautam. Great session. I just want to know about your setup, or how do you set up evals?
Yeah, it depends a lot on the actual feature. The first step is definitely thinking about like the whole shape of the eval. You need to have a high level outline. So that involves two things. One is what should be the distribution of tasks in the eval. So I'll give you an example. So again, let's go to the customer service bot example, right? I'll first think about what are the different types of questions that my customers might ask me. So that is the first step. And then I think about what are the ways in which the response needs to be judged. And the answer to that question is usually something that should correlate to your product goals. So now let's just remove AI from this equation, right? If you actually had a call center, and like every time you have a conversation with a call center worker, at the end of it you get some feedback form, and then you say you give thumbs up rating 5 or 4 out of 5, and then you give some feedback saying how good the service was, how likely am I to come back to this platform. So you have those questions, right? The actual eval can you can actually have exactly those types of questions in the eval. So imagine the different types of questions that the customer can ask, and then the model is giving responses. How would you give feedback to the model? And what are those parameters that will define that feedback? So you define these, so you define all of this. This is what the shape of the whole eval looks like. And then you populate it with different types of tasks. So now I'm like, okay, 30% of my requests are about ETA, 30% is about refund, 40% is about offers, right? I'm just like making up some distribution. Once I have this like high level distribution in mind, then you kind of generate these like different questions from different sources. Like you might, if you have access to, like if customers have consented to donating their questions or their calls, you can use those sources to pull into your eval, or you just like make things up. Like you use like ChatGPT or Gemini to just come up with different types of questions, like verbatim different questions that users might ask. So you need to generate that eval set. Make sure you have like 100, 200 examples at least to start with. Define the parameters, make sure those parameters make sense for your product, and then you just run one round, and then you see how that looks, and then you keep iterating on top of it. Is that helpful, or did you want like some specific detail?
No, it helps. Thanks, Gautam.
Sure.
Awesome. I think we are 40 minutes over time, but I think it's all for the good. I think everyone had a great session, and that's why the session has run really long and a lot of very interesting questions. Gautam, do you feel it's okay we can wrap up the session, or do you want to probably take one?
Maybe if we can take one last question and then wrap it up. If someone has a question. Yeah, Mohammed.
Sorry. Yeah. I have one last question. So like you said, people are evaluating on the chat. They're saying that if this was a thumbs up for the question or not, right? But that could be very confusing from a user standpoint, right? Because the user could be evaluating, let's suppose, the agent, if they gave them a relevant response, or they could be frustrated about their own order, right? So when I'm showing a thumbs up or a thumbs down to the user to test out that was my question correct or not, I'm not really sure if the user is evaluating my question. They may be evaluating their order, they may be evaluating the agent, they may be evaluating their question. It could be a mix of all those three. So I think in such cases, of course, I should be less depending on that, and I should be more depending upon the complete traceability of that query, right? If what exactly happened there. Otherwise, my results would be very skewed. I mean, that's one thing I could think of. Yeah.
Yeah, you can account for this in your evaluation itself, right? So you can have like positive and negative outcomes. Like someone actually got a refund and someone didn't, and then look at the response ratings in both cases, and you can see how which ones are actually correlated to actual quality. So again, this problem is not unique to just using an AI chatbot, right? This is even in a regular call center, you can have this exact same problem. The way you would factor those other variables in and normalize for those variables, you can literally do the same things here as well. It's not any different from that.
Sure, I guess.
Yeah.
Super. I think this has been a fantastic session. Personally, for me, it was a great recap of some very, very interesting nuances that I learned. I think to summarize for myself, the notion of using design as one of the most powerful flywheel elements to help a machine understand the notion of how errors compound, especially with all these agentic talks that's going on. Everyone talks about this perfect system, but understanding the nuance of how errors compound, I think, is very, very critical. Because as you said, a 90% accurate system in step one, if there are many systems that start compounding and working together, eventually the number of passes that it has to undergo to finally give a meaningful outcome for the end business value then drastically changes. So keeping a track of all of that, and then the notion of loss functions, etc. I think this has been fantastic for a lot of folks who have probably not gotten a chance to work on AI products. I think this becomes like key primers that they need to keep in mind. And you have been, going through deep into those examples, details, and I think that's been very, very helpful. I don't think we can find any of this kind of information if we had to search on the internet. So thank you, Gautham, for taking your time out and walking through us in great detail and sharing a wealth of knowledge with us. Really, really appreciate it. And thank you, audience, for staying tuned for a really long session.
Thank you so much, folks. I had a lot of fun. I hope folks also took something useful out of it. And thanks a lot, Deepak, for hosting this whole thing. This was my pleasure to speak here.
Thank you. And also on a Friday night in the US. So really appreciate you taking your Friday evening out with us.
Thank you.
Awesome. Looking forward to probably another session sometime in the future again with Gautham. And thank you all once again for turning up on a Saturday morning and being such an amazing audience. Yes, I will be sharing this recording on YouTube. I'll put it up on LinkedIn so you can then access it from there. It'll be on my YouTube channel. And if there's anything else, just feel free to reach out to Gautham as well. He's accessible on LinkedIn. I've shared the document which has all the links as well. And if there's any other questions, feel free to reach out to us. All right? Awesome. Thank you, Gautham. And thank you, folks. Have a lovely day.